tell you what we're doing. We're taking 3 days to touch on some vocabulary in chapter 6. Chapter 6, there's like a lot of crazy stuff we can do with triangles, but it's totally not necessary to do all the crazy stuff with triangles. So instead, we're going to touch on the important vocabulary and take a quiz. And then when we come back in January, we'll start in Module 7. Okay? Now, we are going to go through 3 days of Chapter 6 and then take a quiz and then study for our final. And that's the semester. Okay? Okay. So, perpendicular bisector. It's 2 words. Philly, what does it mean to be perpendicular?
2 right angles.
Okay. And what does it mean to bisect? Charles? Okay. So we are talking about either a line or a segment or a ray that passes through the midpoint of a segment and it is perpendicular to it. Okay. Yep, it. I mess up. Okay, so that dark green line that I drew is a perpendicular bisector. It is bisecting the segment at a 90-degree angle. Okay, now we have a couple cool theorems that we can use with a perpendicular bisector. Do what, Corbin?
Josh told me to write this.
Hey, Jacob. Also, Jacob, your charger's over here.
Oh.
Okay.
See, Logan?
give it back to you.
No, you never gave my charger back, Logan.
Actually, I did. You just didn't grab it.
What?
What
What?
does that mean?
Jeez, I'm not saying.
Silence in my right.
That wasn't kind. Okay. The perpendicular bisector theorem. If a point is on the perpendicular bisector, then it is equidistant from the endpoint. I'm going to let you write it down, and then we're going to draw the picture together, talking through what the heck this means.
No, my pencil.
Okay, here is a perpendicular bisector. Will you draw it? And then will you draw a point on the perpendicular bisector?
Josh, give my pencil back.
big a loop is for search for crime shall yeah. I need this.
10 o'clock is late for a lot of people.
I am.
Okay, wow. That took a turn.
You go to bed at 7:30 p.m.
I go to 8.
Okay, so if we have this, then this point right here is equidistant from our endpoints. So these red lines that I'm drawing are equidistant. We can assume that when we have a perpendicular bisector because of this theorem.
Oh, yeah. I predicted it.
Okay, so then raise your hand if you can tell me what the converse is going to be.
What's Converse?
If it's not perpendicular.
Nope, that's not the converse.
Forward and back.
It's the switch. So what would that be, Joshua?
Bisector perpendicular.
If it is equidistant from the endpoints of the perpendicular bisector.
If,
What did you?
then.
Wait, so I was gonna
You said bisector perpendicular. Oh, man. All right, so if a point is equidistant from endpoints of a segment, then it is on the perpendicular bisector.
Wait, I don't get it. So what's the difference? Josh, you talk to me. You just broke the pencil.
Okay, so this one is if I know that this point is equidistant. So this is the if. Then I can be like, oh, it's the perpendicular bisector. Okay, so we need to be able to use both of those theorems to solve. We also need to be able to identify, oh, hey, that's a perpendicular bisector. Okay, so look at example 1. I'm telling you that FG is the perpendicular bisector of EH. Now, I wouldn't need to say that because you can tell from the diagram. Okay, so if we have this perpendicular bisector, what is to be true about EF and HF? Okay, so we can say, cool, 4A minus 15 equals A plus 12. Is that what I'm asking you to find, though? Okay, I'm asking you to find EF. EF is what?
21.
No. If it's a measurement, we have 0 hat. Mm-hmm. Okay. What about example 2? So what's happening is since these are equidistant from our midpoints, then we can conclude that this is a perpendicular bisector. So 17x minus 3 equals 9x plus. Are you okay, Josh? Okay. So what does this mean?
X equals 2.
Okay.
Me too.
Esteban, right?
Yeah.
You don't know
Yeah.
Take my joke.
It's not your joke.
Okay. An angle bisector angle bisector.
Yeah.
I wonder what that is.
Bisects the angle. Okay. Ray or a line or a set. That says line. That divides our angle into 2 equal parts. What?
Like, I thought you used some big words.
Please tell me how simple I should have made it.
Bisects an angle into 2 parts.
Well, I can't use bisector in it.
Why?
It's definition.
Well, we already know what
You use
it
perpendicular in the definition for the
Oh, well then I better go change that.
No, we're good, Miss Holman.
There's no
But we know what these words mean though.
What's for lunch?
There. Okay. Line segment array. That's splitting our angle into 2 equal parts. Okay? So just like with a perpendicular bisector, we have a theorem about the angle bisector. I'm sorry. Okay, I'm going to let you write it down and then we'll draw the picture.
Roman, what just happened?
That's my fault. I set my iPad down and it hit a button on the projector.
That's an angle.
Just going to look at something in attendance. Okay, sounds like you're done writing it down. So, if
Oh, yeah, me.
I have an angle bisector, yeah. Oh, that's too bad.
Like bacon.
Jay's shaming pigs for their looks. Faces. Wow, like they thought you looked like pigs.
Okay, if we have a point that's on the angle bisector, then it is equidistant from the angle sides. So that's a bad picture. So not only are these red segments the same, but distance is measured perpendicularly. So we have cute little right triangles.
What?
Do you want me to fix this one? There, that might help. There, does that help? Does that look better? Okay, so Josh, the converse would be bisector angle. Hey, Josh, I tease you because I enjoyed that version of it. Okay, so now we're gonna go backwards. If a point in the interior of an angle is equidistant from the sides of our angle, then it is on an angle bisector. Oh, sorry, Jen. Okay, so if it's on in the interior and we're equidistant, then it's an angle bisector. Oh, why did you cry?
Because I miss my cat.
Oh, I was so tired.
Okay, you miss your cat?
7:30 is such late.
What happened to your cat? I'm sorry.
Sad because she died while we were sleeping.
Oh, that is a bummer. I'm sorry. Okay, so let's look at example 3. Excuse me. Okay. What is ray JS? It's an angle bisector. And since it's an angle bisector, then we know these two segments are congruent, which means 3x plus 5 equals 6x minus 7.
That's pretty fun.
Doesn't this mean 3x equals 12?
Yeah, and then you get 4, and then you get 17.
Okay, what do you mean we get 17? Oh, I asked you to find SP, and SP is 6x minus 7. Sorry, I'm gonna explain myself real quick.
Oh.
I know that I have been on my phone. I'm sorry. Next week we're doing like a secret Santa exchange amongst the teachers.
Who do you got?
I can't tell you. But the person I have, trust you? No. The person I have likes Wicked. Where
It's Mr. Swanson.
where my parents live, there's the Wizard of Oz Museum. So I'm having her buy me a couple things to give to my person.
Is it?
So,
Who likes the wizard?
Oh, yeah, I'm a teacher.
okay. Example 4.
We just went from
It's okay. Hey, what's happening?
They're equal.
Why?
Oh, wait, it's angle side.
The angle bisector angle.
Yes, because it's the bisector angle theorem.
Oh, yeah.
Yeah. So 3x
30.
equals 30. X equals 10. Yes, whoop-de-doo. I know. This is unexciting. Okay. We have one more page. Won't take us long. Okay, I need you to know what a median and an altitude is. Okay. Oh, okay. So I'm hearing the median's the middle of the road. What did you just say?
Midpoint.
Something about a midpoint, probably, right? So, in a triangle, we are talking about the line segment. Whose endpoints are a vertex of a triangle and the, say the word again, Logan, midpoint of the opposite side. Do you know what a midpoint is?
Yeah.
Okay. So let's pretend I pick this vertex right here. Vertex is just one of the corners.
Oh, wait.
So that means I'm going to go to the opposite side and connect it to its midpoint. Whoops.
Okay, I get it.
Like that. Okay. Altitude. Do you know what an altitude is? Ah, okay. So when we talk about altitude, it's how high is the mountain? Okay. So altitude, that was not an appropriate comment. Altitude is how high is our triangle. Okay. Now, we measure height using what kind of a segment?
Base times height divided by 2.
But what kind of segment?
Bisector.
Right.
A midpoint.
It's not a midpoint. It has to be perpendicular.
Yeah, bro, I said that.
Who did it, guys?
It was Billy.
Pineapple.
I'm sorry.
Zero.
No, I was zero once. I don't like it.
Quattro.
Okay, so if I'm gonna draw an altitude, I'm gonna go from the vertex of the one of the vertex of the triangle, and I'm gonna draw the segment so that it is
Straight down.
perpendicular. So when you find the area of a triangle, you need the altitude for the height. Yes.
Does it have to be straight down? Like, does it have to be the top?
Yes. I could have drawn that. Okay. Yep.
What if it's like both of them?
So we're only going to draw one at a time. So there's technically 3 different altitudes in there. But I'm only ever going to have you draw one at a time. Look at number 1 down there. Okay. We need to identify all of these blue segments. No. What is number 1?
Perpendicular bisector.
We have 4 different words. What?
Perpendicular bisector.
Perpendicular bisector. Okay.
Just do like PB or PBC or.
That could also mean peanut butter, so no.
Okay, what's number 2? Median. Because it's yes, this is getting bisected, but it's connected to the vertex. Okay? Number 3. That one is an altitude. Yes, number 4 is a perpendicular bisector. What's number 5?
Median.
Median. See, you're getting the hang of this. Jay, what do you feel about number 6? See, you got it. What's number 7?
Yeah, that one. No.
Because the angle's getting cut in half. Yeah, angle bisector.
Just angle bisector.
Yeah. 8 is weird.
8 is a lot.
It's median. No, it's altitude.
It's an altitude. When we have an obtuse angle, we have to extend the side in order to draw the right or the perpendicular